Greetings, I am Dr. Mad.
And I'm Green Arrow. So,
Ugh, why must I deal with imbeciles? Welcome to your new chemistry class. So, listen up. Today, we're looking over Miss Purvis's assigned Standard 3, which will be explained by our protégés. In Standard 3, we will look over matter and its classifications. You're doing. Keep going.
for starters, matter is, quote, something that has mass and exists as a solid, liquid, gas, or plasma. So today we'll talk about this and the compounds of elements, which are matter, or so in this case, the compounds of matter.
So first, we'll be talking about the role of nuclear fusion in producing all elements heavier than helium. It's very funny. What? Don't judge.
Okay, so what is nuclear fusion? It sounds like a horse's.
Oh no, I assure you it's not that.
Sure, still sounds like it to me.
To explain what I have just said of the role of nuclear fusion in producing all elements heavier than helium, we have what number was it? Oh, yes, that. We have two of our protégés, R and K, to explain. Go, R and K. Go, go, go.
Hello, I'm R.
Hello, I'm Kay.
In today's news, we're going to be talking about nuclear fission. The event of two or more nuclei being joined together or so-called fused to form a single heavier nucleus.
Okay, what does this do in making elements heavier than helium? When all positive charges repel, we must put the energy into the reaction, pushing the nuclei together against their electric repulsion.
Really?
Yes, really.
Therefore, the more strongly charged, the more energy the atom requires bond. Here's an example of nuclear fission. As you can see, the two nuclei are being joined together to form a single heavier nucleus, which is right here.
And back to you, Dr. Mad.
Ah, such lovely students.
Shh. Oh, yeah. Lovely students. Sure. So what does that all mean?
It means, my simpleton, that nuclear fusion helps combine nuclei, forming compounds for elements. So nuclear fusion helps you discover how compounds form, such as H2O.
Whatever you say.
You are a disgrace to science!
Alright, fine, kids. What's next is IDing substances based on chemical and physical properties. Okay, what are those things?
Chemical and physical properties, you say?
Yeah. You know about them?
Of course I do. I'm Dr. Mad.
Can you explain them to me then?
Of course not. I'm Dr. Mad.
You are just a very unlikable person, aren't you?
Yes. To explain the next section, we have C, or Protégé C, to explain, because the other one is kind of dead. Yes, our protégé died. So here we go, explaining to ID substances based on chemical and physical properties. Go C. Hello, students! I am Protégé C. Oh no, I forgot my lines. Oh yes. The textbook definition of physical properties are any property used to characterize matter and energy and their interactions. Whatever that means. They don't change the chemical nature of matter, these physical properties, and really physical properties can come down to how it looks. So, for example, we have ice. A physical change would be this. Ice melts into water. It's physically changing, but its contents itself are not different. Which brings me to example 2, which is chemical changes. Chemical changes, let me say, a property used to characterize materials in reactions that change their identity, and that's what a chemical change is.
So in this sense, what it means is the inside itself are changing. What makes that element an element is finally changing. So, did you get that? You probably didn't, so let me explain. Physical, changing very much so. Chemical, the insides of it. What makes it an element. I hope I got that right, because Dr. Mad will probably kill me. Back to you, Dr. Mad.
Now, does it make sense, Green Arrow?
I'm kind of starting to get the hang of this. What doesn't make sense is that you keep changing your voice.
Nonsense! Oh dear, I fell.
Please, put me back up.
I don't think I am. Please, I can't come back up.
No, so, what's next?
I'm still stuck. Well, the Green Arrow did not help me up. He has been taken care of.
No, I haven't.
Silence, madman! Anyhow, next up, for Standard 3 on matter, we have...
That was awesome. Alright, little ladies. Next up we have to show and predict formulas for stable ionic compounds, both binary and tertiary, based on the balance of charges. Want to find out what that means? Of course you do. I'm the Green Arrow. So, here we have back to KNR. Go ahead, KNR.
I will destroy you when I get back up!
Binary compounds are compounds that have two parts or elements. Here's a picture to explain it.
This is called binary and ternary ionic compounds. Follow us to the board as we show you how to explain it.
Okay. Right here, say the ionic bond with a transition metal. Transition metal will have a charge depicted by Roman numeral. Okay, Roman numeral 1 is 1 charge. Roman numeral 2 is 2 charge. Roman numeral 3 is 3 charge, and so on. And let's refer back to the chart again. They say you +1, -1. The oxidation numbers of the iron oxygen. Fe2. O3 equal iron oxide.
Tertiary compounds contain at least 3 elements. Compounds using nonmetals are known as polymetallic ions. Here is a picture showing a tertiary compound and a polymetallic ion. Ionic bond without a transition metal. Metal's name.
No, my students, no! Didn't you already show that? Don't you have anything else to say? I'm Dr. Mad. Don't laugh at me. Keep going.
Okay, how do you predict the formulas for ionic bonds? You use this number system to explain it, which I already have done explain it already. Roman numeral 1, Roman numeral 1, all the way to Roman numeral 6.
So, tell us, Kay, what does binary compounds mean?
That means it have 2 charges, right?
I thought you said 2 or more elements.
That is also true.
Oh, okay. And tertiary is?
It has 3 or more elements.
I love you, my students. Is that all you have to say?
That's also
See it,
what
bro.
it is.
Good.
Yeah, real talk, bro.
Yeah,
Alright,
real
have a
talk,
favor.
bro.
Say goodbye.
Alright, bro. Yeah.
Oh, they're so beautiful.
What's beautiful?
My students. They make me so proud.
Miss Purvis never does that.
What's your point?
So that means she's not weird, and you're weird.
Wait, did you just call me weird?
Oh, here we go again.
The reason we learn about compounds is because by learning how they match up, we can discover just what elements can combine to create whole new elements. Like this, if you combine hydrogen with oxygen, you get H2O, my little minions. Or, as we call it, water. It also helps us discover how you match them together. Is it starting to make sense to you, Green Arrow? Is my teaching working?
Nope, I miss Miss Purvis.
And now for...
The grand finale.
Thank you, Green Arrow. For the grand finale, ladies and gentlemen. for our final part, the standard is
How we use IUPAC nomenclature for chemical names and formulas found in the notes. And you have to find the ionic, covalent, and adic compounds binary and tertiary for, using IUPAC nomenclature. Or as he says, we're going to use nomenclature, IUPAC nomenclature to be precise, to find the chemical names and the formulas of ionic, covalent, and adic compounds, using all of our proteges. Go, my proud proteges, go and do daddy's wonders.
Hello. Say hello. Yes. Well, so binary is 2, which means there are 2 elements combining into 1. And tertiary is 3. So, what we have here, if you see, is covalent bonds. Now, say here what it says.
Covalent bonds are -2 non-metals.
Elements. So, in this sense, if we have hydrogen, which is 1 and 2, and then 1 and 2 of hydrogen combines into 1. But we have a physical example over here if you focus. So, what all this nomenclature means, this is the chart. Stand aside, Ronnie, the people are trying to see. Thank you. Is this right here. That is IUPAC, as we would say, nomenclature. But here's the point that you need to understand. H2O, O2, Cl2, and I2, and Br, bromide, these are all diatomic elements. And anything above 2, such as S8 and P4, are polyatomic elements. Dia, 2, anything above 2, poly. So, what does this all mean? Okay, what we are trying to understand, we're trying to see how we name the elements, how we put the formulas out for them, how they work. So, if we can bring this down just a tad bit, Ronnie, I don't think it's working.
Should I use the mouse?
Oh yes, the mouse. The mouse. The beautiful mouse. Yes, yes.
Right there?
Right here. So, help me explain it. Okay. So, if we have the prefix Marlow, which means 1, we have the prefix D, it means 2. If we have it tri, it means it's going to be 3 elements. 3 things. Now, example. Keep on, continue.
Okay. This is penta, I believe. It's 4. Penta, which is 5. Hexa, which is 6. Septa, 7. Octa, 8.
So what does that mean? What it's saying is the number of atoms. So if you make a word, Marlow, it's going to have 1. Or if it's septa, that means it has 7 atoms. And as we know, 7 of the atoms and all that would mean the atomic number. So, in this sense, H2O, what is H2O?
Water.
Water, hydrogen oxide. So, dihydrogen monoxide, or N2O5, dinitrogen pentoxide, or PC13 phosphorus trichloride. So what I'm saying is, this is the formula of what you're getting at, of the 2 elements and how many there are. So there's 3. So it's P and Cl. Now what are those elements? Dr. Matt can kill me if I don't know quick. It's the elements Cl. I think it's chlorine. I hope it is. Well, it's saying there's 3 of them, and this is phosphorus. Oh no, it's chloride. Chloride. So there you go. What I'm saying is this. You have phosphorus, just here, chloride, but since there's 3 in chloride, 3, phosphorus, trichloride. This right here is just another word for this, and this is just another word for this, which is really just phosphorus and chloride combining to 3. That's all it is. Now, where did you put our notes? The last ones I had in my hand just as
I put it down on the table.
Yes. No. Where's the last page of the notes? Where's the page? It doesn't seem to. Well, I think pretty much I got my point across. What do you think, Ronnie?
I think we got
That's how you can find it. Remember, binary is 2, tertiary is 3, and is that it? That's about it. I think that's it. And ionic. So combine what you learned about binary and tertiary and ionic into those when you're trying to find the nomenclature. So I hope that helps, and we hope Dr. Matt doesn't kill us if we did badly. Goodbye.
So, in the end, Dr. Matt, what did that just mean?
What it means is that what you just saw is a formula for finding covalent, ionic, and adic bonds with their examples.
There's no catch?
No catch, my good friend. No catch at all.
You can stop being creepy at any time.
Of course. So, I think that's it. Do you understand?
Of course I don't understand. But it doesn't matter. I'm still cool. I'm still green arrow.
Ah, shut up. So, that's it for everyone that you just learned Standard 3. What we just told you about is matter, how it combines, and what it means to combine. And if not, research yourself. Find out more. Maybe we didn't say something. Find out what it all means. So, that's all the notes and such of our presentation. So, Green Arrow, did you take your notes? Do you understand? Did I finally get something in your head? Even without our fourth protege to physically help us at the time.
You really want my answer?
Yes, I want your answer. Tell me now.
The answer is I still like Miss Purvis better.
Are you serious?
Yeah, I still like Miss Purvis better.
Dun, dun, dun.